Hello, welcome in this channel, Mausam Science. Today, we are here to solve the practical of physics. Today, we'll study about the solar flux density variation with time. Okay, in this practical, we need the apparatus called a pyranometer, stopwatch, and other device for maintaining the data in your data copy. Okay, before starting, we'll see what is a pyranometer. A pyranometer is a scientific instrument used to measure the solar radiation received from a hemispherical field of view. In a hemispherical field of view, whatever the solar radiation we receive, okay, hemisphere we know, and that is called a pyranometer. That is a device to measure the solar radiation. And how does a pyranometer work? Okay, I'll come to this question later. But before that, I would like to show you the device called pyranometer. This is a pyranometer. Okay, it consists of this measuring device and a counter. Okay, to measure the data. Okay, we'll set up this counter to watt per meter square. Okay, we'll set up here and we'll keep this in a direct sunlight. And whenever we keep it in the direct sunlight, we can get some value. Okay, the value is shown over here. This is the value which we get whenever we keep this in a direct sunlight. So this is the working mechanism of pyranometer. Now I'd like to come to this question. How does a pyranometer work? A pyranometer works by using a thermopile sensor. There is a thermopile sensor which convert heat energy from sunlight into an electrical signal proportional to the solar radiation intensity. That means whenever the solar radiation intensity increase, the rate of conversion of heat energy from sunlight to electrical signal gets increased in a proportional way. What does a pyranometer measure? A pyranometer measures the global solar radiation, which include both direct solar radiation and diffuse sky radiation. I would like to explain about this. Okay, suppose here is a sun. Okay, this is a sun, and in our atmosphere we have several um, things like cloud, dust particle, okay, raindrop, water droplets. Now, if there is a pyranometer device here, let it be with a symbol P. If the radiation comes directly from the sun, this is called a direct solar radiation. If the radiation gets reflected from this surface, this is called a diffused solar radiation. Okay, I'll write here this radiation as a direct and the other radiation as a diffused. Okay, if there is a water droplets and all other things in the atmosphere. Okay. A pyranometer measures the global solar radiation, which include both solar radiation and diffused solar radiation. Now, what are the common application of pyranometer? Pyranometer are used in meteorology, climatology, solar energy studies, okay, and for monitoring the efficiency of solar panel, okay. This is very interesting. That means pyranometer also convert sunlight to electrical signal, and solar panel also convert this sunlight to electrical signal. So in order to monitor this solar panel, we need a device called pyranometer. So now I'd like to move to experiment, how to do this experiment. This is a pyranometer. Okay. This is pyranometer and this is a counter for measuring the intensity of this device. And I have explained about this. And its SI unit is watt per meter square. That means it's the measure of amount of solar energy per unit area. Traditionally, pyranometer were mainly used for climatological research and weather monitoring process. But right now, it is used in several different places. We know that. We'll keep it. We'll on this experiment. We'll take a stop watch and the observation procedure. How to observe the data from this experiment. Okay, how this can be done? The place a pyranometer in a complete dark room for 10 minutes. Why it is done? Because if we keep this pyranometer in a complete dark room, it should not show any kind of data. Maximum reading and minimum reading should be zero. There will be no any reading. This is for the calibration or for the checking of if there is any kind of error in such a pyranometer or not. Now place the pyranometer in sunlight. Okay, measure the reading in every 2 minutes. Suppose we took the experiment from 1240, then we set up a stopwatch. We'll take the data of 1240. No, if we start the experiment from 1238, then don't take directly the data of 1238. Wait for 2 minutes, okay? And take the first data from 1240 and 1242, 44, continue the data. And you need to take the 35 different readings. That means 2 minute each readings will be taken. And this is the irradiance watt per meter square. Now, after this, we'll get the summation of I, and if you get the divide the summation of I by number of observation, then you will get the value of average irradiance. Okay. If we subtract the value of average irradiance from this individual irradiance, suppose 570 minus 477.4, and if we square, you will get the data over here, I minus I bar square. That means this is the average value, and you will get the average value over here and plot a graph time versus irradiance. Okay, you will get some sort of graph of time versus irradiance. Okay, whatever the data you get, and from that graph you will get the value of m and c. Okay, slope, and the value for y-intercept c. Okay, dy by dx, but we'll not focus over here. We can plot the data, whatever we have got over here, time versus irradiance. We have the value for time, we have the value for irradiance. Okay. And after that, we'll take a standard deviation. That means root over summation of I minus I bar square by root over n. That means the value I minus I bar is over here. Root over n means 35. 35 different data is taken. That means 77.23. And standard error is taken by dividing standard deviation by root over n. If we divide 77.23 by root over 35, we get the value for 13.05. That means our data has been fluctuated by 13.05 value, which can be added or subtracted. Now we will calculate, this is our experimental data on the surface of Earth, because pyranometer is kept in the surface of Earth. And after that, we know the value for luminosity of sun, that is 3.83 into 10 to the power 26 watt, and the distance between earth and sun is 1.5 into 10 to the power 11 meter. Now theoretical value. Theoretical value for calculation of solar irradiance is divided by luminosity of sun is divided by 4 pi d square. 4 pi d square means we have the value for d, distance between earth and sun. That means we have got the value for irradiance, that is 13.79 watt per meter square. Now, what is this value? This value is for the okay. I will pick up a pen for drawing over here. Okay. Suppose this is our Earth. Okay. We have a several layer of atmosphere in the Earth. Suppose in the outer layer of atmosphere, if we measure, then we can get this type of value. That means our calculated value was 477.14 in the surface of Earth, and theoretical value on the upper layer of atmosphere is 1379. That means there is the change in value whenever we measure it on the surface of Earth. That means by how much the value get reduced. That means percentage of reduction is 65.38%. There is the reduction value. Okay, hence irradiance got reduced by about 65% when it reaches to the Earth atmosphere. We have got this conclusion, and finally our experiment is over. So in this video, I have shared my knowledge, whatever I have. Okay, how to do the experiment to calculate the solar energy density, solar flux density, and how to use pyranometer and how to get the final result. So if you have any kind of confusion, please leave the comment in a comment section. We'll see you again. Bye bye.